Okay, get this. What if an AI could learn to see the world, not by us hand-feeding it millions of perfectly labeled photos, but just by reading the internet? It sounds a little wild, right? Well, today we're diving into a really radical breakthrough that does exactly that. It teaches machines to understand images using the one thing that's literally everywhere online: text. So first, let's talk about a weird problem that's been bugging AI researchers for a long time. We've got these incredible AI models that can identify 1,000 different types of flowers, right? But then you show one a super simple sketch of a cat, and it just has no idea what it's looking at. It's totally lost. So why are these supposedly super powerful systems so brittle? Well, it turns out the answer isn't about how powerful they are, but about how we've been teaching them to see in the first place.
And this really gets to the heart of the difference. On one side, you've got your classic AI vision. Think of it like it's just memorizing millions of digital flashcards. This is a dog. This is a cat. This is a chair. It gets really good at that for sure, but it's super rigid. And then you have us, human vision. We don't just memorize labels. We learn from context. We hear someone say, "Oh, look at that fluffy little puppy," and our brain just instantly connects the words fluffy puppy with the image, the feeling, all of it. Our understanding is way more flexible, way more robust.
All right, let's dig a little deeper into this old way of seeing. For decades, pretty much all the best AI vision models were trained like this. You had to create a giant, and I mean giant, expensive set of those digital flashcards. We're talking millions of them, all labeled by a person, by hand. And as you can probably guess, this is not only incredibly slow and super expensive, but it creates a really fundamental problem. And here it is, the big bottleneck. So what happens when you want the AI to learn something new, a visual concept that just wasn't in those original flashcards? Well, you pretty much have to start all over again. You got to go out, collect thousands of new images, pay people to label all of them. The whole process is just unbelievably slow, expensive, and totally inflexible. It's a huge pain.
Okay, but this is where the really big idea comes into play. Some researchers at OpenAI asked a pretty revolutionary question. They said, wait a minute, what if we just stopped hand-feeding AI these perfectly curated data sets? What if instead we just let it learn from the messy, chaotic, but absolutely massive library that is the internet, just by connecting images to the captions people are already writing for them? And this brilliant idea is called CLIP. It stands for Contrastive Language Image Pre-training. The goal here isn't to get the AI to spit out a fixed label like cat or dog. Nope. Instead, CLIP learns a much more fundamental skill. It just learns to understand which piece of text goes with which image. That's it. Simple but powerful.
And to pull this off, they didn't use one of those clean, perfectly organized data sets. No way. They just scraped a staggering 400 million. That's right, 400 million image and text pairs straight from the public internet. And you got to understand, this isn't just more data. It's a totally different kind of data. It captures this incredible diversity of visual stuff described in just normal, everyday human language. So how does it actually learn from all this? Well, you can think of it like it's playing a massive matching game. The model gets a big batch of images and their captions, all shuffled up. And its only job is to figure out which caption belongs to which image. So for every correct match it makes, it gets a little reward. For every wrong one, it gets penalized. And by playing this game over and over and over again with 400 million pairs, it starts to build this really deep kind of intuitive connection between what text means and what pixels look like.
And all of this training, it leads to a truly incredible payoff. Because CLIP isn't just memorizing which picture goes with which caption. It's actually learning to generalize. And this gives it a kind of superpower, something we call zero-shot learning. It's the ability to do a task that it has never, ever been explicitly trained to do before. Okay, this is where the magic really happens. You don't need to retrain the model at all. You just talk to it. In plain English, you can give it a list of descriptions, prompts, like a photo of a dog, a photo of a cat, a photo of a car. Then you show it an image, and CLIP just tells you which of your descriptions is the best match. It's wild. You're literally creating a custom image classifier on the fly just by typing a few words.
So the big question is, how well does this actually work in practice? And this is the truly mind-blowing part. On the famous ImageNet benchmark, which is like the Olympics for computer vision, a zero-shot CLIP model performed just as well as a state-of-the-art model that was meticulously, carefully trained on that entire dataset.
Let me say that again. Clip had never seen a single one of ImageNet's 1.28 million training photos, and it still matched the performance. That's just staggering. And take a look at this. It really shows you how powerful this whole approach is. So, on that general ImageNet dataset, yeah, it's competitive. But look at what happens when you move to more specialized tasks. When it comes to identifying, say, specific car models or different types of food, zero-shot Clip doesn't just compete, it absolutely blows the specialized purpose-built models out of the water. We're talking outperforming them by over 20 percentage points in some cases. It's not even close.
But you know, raw accuracy is only half the story here. There's a second breakthrough that's arguably even more important, and that's robustness. This is all about creating an AI that doesn't just fall apart the second it sees something a little bit weird or new.
This brittleness has always been a massive problem in AI, right? You can have a model that's been trained on millions of perfect studio-lit photos of cats, but then you show it a simple cartoon of a cat or a photo of a cat from a weird angle, and it completely fails. Why? Because that new image is just too different from its training data. And this is exactly where most AIs stumble.
Right, so take a look at this. A traditional model that was only trained on clear photos of puppies might get totally confused by a photo of a different breed of dog, an adult dog that's in motion. But Clip? Because it learned the concept of dog from millions of different pictures and all sorts of text descriptions from all over the internet, it has a way more flexible understanding. It gets the idea of a dog, not just one specific type of picture of a dog.
And the numbers here are they're striking. When researchers tested this on really challenging datasets, the kind that are specifically designed to trip up AI, zero-shot Clip shrunk this robustness gap, the difference in performance between easy and hard tests, by a massive 75%. So what does that mean? It means it's not just more accurate, it's fundamentally more reliable out there in the real messy world.
So let's bring this all together. What does this all mean? Well, we now have a flexible, robust AI that you can basically program using natural language. This isn't just another small, incremental step forward. This is a fundamental shift in how we build and how we even think about interacting with computer vision.
But this kind of power, well, it's a classic double-edged sword. On the one hand, it's incredibly empowering, right? Anyone can roll their own classifier for pretty much anything you could imagine, from spotting actions in videos to reading text and signs, all without needing a giant, expensive dataset. That's amazing. But on the other hand, a model that's trained on the raw, unfiltered internet, well, it learns all the patterns it sees there. And that can include a lot of unwanted societal biases around things like race and gender. And of course, these powerful capabilities could easily be misused for things like mass surveillance, which is something we really have to think about carefully.
And that really leaves us with one final and pretty crucial question. We now have this incredible tool that can be told, just using plain English, to see and categorize the world in pretty much any way we want. So the question isn't really about the limits of AI's vision anymore. It's about the wisdom of our own.